So just a quick update for why I didn't stream yesterday. So yesterday was I took my maths AS level paper one and computer science paper one. So maths paper one was I didn't revise for it much, so I didn't really do much of maths paper one. I think I did like four past papers, and I had like 1 day to revise. So I and then I mostly did computer science paper one, and yeah, I mostly did that. And I gotta say, it's really tiring to like just constantly keep studying. So for yesterday, when I took the paper for Maths P1, it was at 8 o'clock. I took the paper, and I can say it's about the same as physics. It's like you do it, and if you firstly you see it, you realize like this is like very different from what you've done. But when you continue to do it, you just remember like, oh, it's basically the same thing, just written in a different format. But for computers, after that, I just grinded computer science P1 from like 9 to 12. I just kept studying P1 computer science at school. So yeah, it was very tiring, man. It was mentally tolling. And then when I took the P1 paper in computer science, I guess it was worth it to just keep studying. But after, it was okay. The paper, it was quite easy, to be honest. Nothing too hard. Only that one question regarding the instruction groups. I can't believe I did not answer that, and that's just 4 marks gone already. Yeah, just that. I think I can do alright, since it's only that 4 marks that I know I won't get, which is a lot, to be honest. Okay, and then after I did my computer science, I just couldn't do anything anymore. I was so tired. I didn't want to do anything at all. So I just went home and just played some games and just slept. Yeah. I was a bit too tired for that. So yeah, it's important not to overwork yourself. Okay, but that doesn't matter. P5 is tomorrow, and I'm gonna start revising for it now. So it's not too late, because P5 is just the baby version of statistics paper in maths. Alright, let's get into it. So I actually bought another monitor. So now I have two monitors. I was trying to do a dual monitor thing, but of course I can't, because my table is too small for that. So, yeah, I'm trying to sell my second monitor. The one, I mean, it's a really nice monitor, but it has the huge bar in the middle. Yeah, I mean, it doesn't bother me, but it does kind of bother me. Okay, let's move on to P5. I need to make sure I don't make any careless mistakes, because for P1 I actually made one really careless mistake. For the geometric progression, it was supposed to be AR square, because AR cubed minus 1 AR squared, but I just did AR for the third term, which is a huge careless mistake. I think I lost like 3 marks there. If Cambridge is lenient, 2 marks, but yeah, it's just horrible. So I really can't be making these mistakes again. It's this 9709 52 FM 20. The 40 members of the club include Ranulf and Sayed. All 40 members will travel to a concert. 35 members will travel in a coach, and the other 5 will travel in a car. Ranulf will be in the coach, and Sayed will be in the car. In how many ways can the members who will travel in the coach be chosen? Okay. So we already know that Ranulf is in the coach. and in the car will be Said. So we have 38 more members to allocate. 35 will travel in the coach. So out of the 38, only 35 can go to the coach. So from this we can do I want to say 38C5, but I don't think that's the correct one. C35. Is that possible? I kind of think that's the way to go. Just write it down first. 38C35. 8,436 ways. But that's too simple. You want to choose 40, man. 38 out of the... Only 35 out of the 38 will go into the coach. All 40 members will travel to the concert. 35 will travel in the coach. So the other 5 will travel in the car. Oh, so 35 is actually including Ranouf already. So it's not 38C35, it's 38C34. So 4 of them are chosen. So we have 4 more left. Okay, I think it's 38C34. Okay, let's move on to the next question. 2A. An ordinary fair die is thrown repeatedly until a 1 or a 6 is obtained. Find the probability that it takes at least 3 throws but no more than 5 throws to obtain a 1 or a 6. At least 3. Probability that there's at least 3 throws. No more than 5. I'm really rusty on P5. How do I do this one? At least 3 throws, but no more than 5. And okay, the probability is 1/6, and the improbability is 5/6. So honestly, I really forgot how to do this one. How would I do this? Probability is 3, 4, and 5. Oh, it's a 1 or a 6, so you have 2/6 as your probability and 4/6 as your improbability. 3, 4, and 5. Okay, so let's say you throw it 3 times and you get a 1 or a 6. So your first time you won't get it, so you have a 4/6 probability of not getting it. And second time you throw, 4/6 probability of not getting it. And third time you throw, 2/6 probability of getting it. So you have 4/6 times 4/6 times 2/6 plus 4/6 times 4/6 times 4/6 times 2/6 plus 4/6 times 4/6 times 4/6 times 4/6 times 2/6, and that gives you, so we'll do 4/6 times 4/6 times 2/6 plus 4/6 cubed times 2/6 plus 4/6 to the power of 4 times 2/6 we get 0.313. Okay, so the first paper I'm doing is usually just like a refresher, you know, but the second one will definitely be better. I'm already not feeling good about this paper. On another occasion, this die is thrown 3 times. The random variable x is the number of times that number 1 or 6 is obtained. Draw up the probability distribution table for x. Okay. It's thrown 3 times. So we have 3 number of times of 1 or 6, I think. So let's say x1, sorry, 0, 1, 2, 3. Thrown 3 times. Okay. So probability that you won't get any 1 or 6 throughout the whole 3 times is 4/6 times 4/6 times 4/6, which is 8/27, and the probability that you get it once is 4/6 times 4/6 times 2/6, and you would multiply that by 3. because there's a probability that there's a probability that you will get 1 times of either 1 or 6 in either way, like your first throw or your second throw or your third throw, and you only get 1. That makes me think about this question. Find the probability that it takes at least 3 throws but no more than 5 throws. I guess that makes sense. So like you would take 3 throws to get a 1/6, or you will get a 4 throws to get 1/6, or 1/6, or 5 throws to get 1/6. 1/6. Next one, let's say 2 times. So you have 4/6 times 4/6. Sorry, 4/6 times 2/6 times 2/6. So this one you would have 3 different ways of getting 2 times as well. So you have, let's say your first 2 is 1/6 and your last one isn't, or your first and last is 1/6 and your second one isn't, or your second one and third one is 2/6 and your last one and your first one isn't 2/9. And lastly, you have 3 times. So this one's just one word. All of it gets 1/6. So 8/729. Sorry, 1/27. And to verify, we have to add them together and they should give us 1. So 8/27 plus 4/9 plus 2/9 plus 1/27. Yep, they gave us 1. Whew. So, yep, that's correct. See, I like questions that you can verify, because then, like there's this toxic thing, like after every exam you and your friends come out of the exam hall and you just start comparing your answers. You just memorize all of your answers and you compare with your friends, and then once you find out that your answer is wrong, you just feel really shit, especially if like all of your friends get the same answer and you don't. You just feel like really like dumb, like how did I not get that answer? And then how did they all get the answer but I didn't get the answer? So you just feel really dumb. But yeah, that's why usually I don't like staying behind after the exam and talking about that, because you just end up feeling really stupid. No, not really stupid, you just feel bad, unless you didn't do anything wrong, like you get all your questions correct, then you'll feel good, because like you'll all be like comforting each other, like, oh yeah, you got the answer, oh I got the answer too, so it should be correct, like that. So yeah, that's just something that I experienced. Especially like if it's you, but I feel better when you like realize like it's a mistake, like the one I talked about, the R square, when my friend said like, oh no, it's this answer, that answer, and I was like, how did you get that answer? And then I think about it, I spent time thinking about it, I felt shit. I was like, damn, who's correct? How am I wrong? And then once I remembered, oh, I forgot to square it, then I just felt insanely better, because like I myself realized my own mistakes. Okay, next one, find EX. So EX would just be 0 squared times 8/27. Yep, that's 0. 1 squared times 4/9. That's 4/9. 2 squared times 2/9. That's, we don't know. And plus 3 squared times 1 over 27. That gives you 4 over 9 plus 8 over 9 plus, because 2 squared 4 times 2 is 8, and then plus 9 over 27. So we have 5 over 3. That's your EX. Actually, I feel like taking a shit now. I'm gonna go take a shit. Number 3. The weights of apples of a certain variety are normally distributed. Okay. Find the standard deviation of the weight of these apples. So 22% apples have a weight greater than 87 grams. So how we write this is P bracket Z more than greater than 87. So 87 minus 82 over the standard deviation is equals to 0.22, since 22% have greater than 87 grams. So from this we would do the reverse of, okay, let me just get my keyboard again. F19. So let's find what's the nearest to 0.22. So obviously in the normal distribution table, there's no 0.22. So this is, since it's more than, we get 0.22 from 1 minus the actual z value. So now we have to minus it again. 1 minus 0.22, you get 0.78. So let's find what 0.78 is. 0.7794. So here we have a 6, so that 7794 plus a 6 would give us 0.78. So what is that value? 0.772. 0.772. Just write down. Inverse of the phi is 0.772. So here we have, so then that gives us 87 minus 82, standard deviation is equals to 0.772, which gives us standard deviation is equals to 87 minus 82 over 0.772, which gives us 6.476. Just put it to 3 significant figures. 6.48. Okay, moving on. B. Find the probability that the weight of a randomly chosen apple of this variety differs from the mean weight by less than 4 grams. Certain variety with mean 82 grams. Difference from the mean weight by less than 4 grams. So that just means we will do, okay, differs from the mean by less than 4 grams, so it can be more than or less than. So we'll do P. Let's try and do 87 minus 4, which is, the mean is 82, sorry. 82 minus 4, we have 78, or so it's mean weight by less than 4 grams. Differs from the mean weight by less than 4 grams. Yeah, so it has to be more than 4 grams of difference. So 78 x less than 82 plus 4, 86. So from here we do 78 minus 82 over standard deviation 6.48, z value 86 minus 84 over 6.48. So P would give us negative, okay, let's just do 4 over 6.48 first. That will give us 0.61, so we know the other side would be negative 0.617. So from that, we can just draw the distribution curve first, just to make you like have a better idea of how it's gonna be written. So we have 0.617 on the right side and negative 0.617 on the left side, and it will just be in the middle. So you would have phi of 0.617 minus 1 minus phi of 0.617, which gives us, what is 0.617? 61, 7291, and 7291, 7291 plus 23. That will give us 7314. Yeah, I think that's correct. Okay, 7314. 0.7314 minus 1 minus 0.7314. So that gives us 7314 minus 1 minus 0.7314. 0.4628. Simplify 0.46. Let's put 463. Okay, moving on. 4. Sorry. Need to do something really quickly because I'm running a game recharge thing, so I'm helping people recharge their game stuff as well. So yeah, I'm just doing that just to get like some extra side income, just a little bit. I have a customer. See, $8, 344, about the same. 336. Okay. You can pay cryptocurrency. Oh. Hey, I just need to grab something. Just give me a second. The cat's in the room now. Oh no. You dropped the calculator. So my calculator, funny thing, my calculator actually broke. Damn. It broke. It was the whole lower display is gone. Look at it. It's dead. The lower display is gone. So I get nothing when I equate. I get nothing. So when you get a new one. Damn. Okay, time for me to just make the purchase. Okay. Gotta send this over to the customer. Okay, it's done. Let's continue on with the paper. Richard has 3 blue candles, 2 red candles, and 6 green candles. Candles are identical apart from the colors. He arranges the 11 candles in a line. Find the number of different arrangements of the 11 candles if there is a red candle at each end. So Let's just visualize it. We'll draw. Hey, stop scratching. So I don't mind that scratching actually, but they're like pulling up the carpet from the ground. What? Rectangles at each end. Draw out 11 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So visualizing it, we'll have red at each end. So since there's red at each end, they are fixed. So we don't have to take them into account. But we do have to take into account the other candles. So we have, actually we have, you can cycle. You can have 3 different arrangements of red candles. Oh, sorry, 3 different arrangements of red candles at the end. So we have one, let's say we have candle A, candle B, candle C, since there's 3 red candles. Oh my gosh. So you have, let's say we arrange it as, first one is A and B are at 2 ends. That's the first possibility. And next one, A and C are at the 2 ends. So that's the second possibility. Third one would be B and C at the 2 ends. So that's the third possibility. And that's all our possibilities. So you will have 3 possibilities, and the rest in the middle is just 11 candles minus the 2 that's being put in at the ends, so 9 factorial. So 3 times 9 factorial. You get 108,8640 ways. Moving on, B. Find the number of different arrangements of the 11 candles if all the blue candles are together. And red candles are not together. Okay, I'm never good. I was never really good at like permutation and combination. You know, like thinking back to the first question, I don't think we actually need to multiply it by 3 because they're all the same. They're all the same candles. It's nothing really like different about them. But there is 3 possible scenarios. Do we count those? Okay, I'll just leave it there first. We'll find out later. Find the number of different arrangements of the 11 candles if all the blue candles are together and the red candles are not together. So for this one, how many blue candles are there? 3 blue candles. Oh, there's only 2 red candles. Another kiwi smoothie, I think. I read that wrong. It's actually 2 red candles. So there's only one possible scenario. So you would just have 9 factorial, which is 3262880. Moving on, B. Find the number of different arrangements of the 11 candles if all the blue candles are together and the red candles are not together. Let me think about this one. So firstly, let's just find the possibility that the red candles, the total possibilities first, which is 11 factorial. Giving us 399,16800. And for the second one, let's find the possibility that the blue and red candles are together. Sorry, let's just find the red candles being together first. Red candles being together, so let's draw a diagram again. The red candles were together. We have 10 spots for the red to go to, so we'll have 10 factorial. If we take away the amount of times that the red candles are together and compare it, if we take away the red candles together from the total number of possibilities, the red candles we'll get the possibility of the red candles never being together. So we also need to do that for the blue candles, but we want them to be together. So let me think about it. How would we do this? So if all the blue candles are together, I think we try and find the possibility of the blue candles not being together first. So we have B, B, B. So the blues are not together. Wait, but that's a very big possibility. We have like a lot of different ways to do it. Okay, I'm gonna leave this blank first. We're gonna find out later. So, like I said, the first paper is the trial. 5A. In Greenton, 70% of the adults own a car. A random sample of 8 adults from Greenton is chosen. Find the probability that the number of adults in this sample own a car is less than 6. So probability of it being less than 6. And there's a total of 8. 70%, so our P will be equals to 0.7. So let's just do let's do 1 minus probability that it's more than 6, more than or equals to 6, since it says less than 6. The probability that it's less than 6. So we'll take it more than, what's it called, at least 6. 1 minus the probability that it's at least 6. So we will have 1 minus HC6 P R so R will be 6, Q 0.3, N minus R 2, plus HC7 P 7 Q N minus R plus HC8 0.78 Q 0. Okay, from this we will get 1 minus HC6 0.76 times 0.3 square plus HC7 times 0.7 to the power of 7 times 0.3 plus HC8 times 0.7 to the power of 8 times 1. We will have 0.1 minus 0.5517, and that will give us 0.448. So we'll just do 0. Let's leave it at 448. 0.448. That's the answer. Moving on, B. There's now 120 adults. Use an approximation to find the probability that more than 75% of them own a car. So for AS it's really simple because they already tell you use the approximation. So yeah, it's really simple. But for A2 they wouldn't tell you, you'd have to find out yourself using like conditions. Like your NP must be less than 5 to use approximation. Okay, let's get to it. So for this one you will have to use NP. So 120 times 0.7 giving us, since the probability is 0.7, 70% of the adults own a car, so it's 0.7. 120 times 0.7, 84. And your NPQ is a variance. So 120 times 0.7 times 0.3, giving you 25.2. So from here, you would use your normal distribution. More than 75 of them own the car, so more than 75. But since you have to use approximation, you want it to be more than 75. So you add 0.5 to it. Yeah. So P will be X more than 75.5 minus 84 over root of 25.2. What do we get from that? 75.5 minus 84 over root 25.2. We get negative 1.693. And then from this, our answer would be the 1 minus phi of, oh no, sorry, it's just phi of 1.693. So using the MF19, 1.693, we get 9548. 0.9548. Rounding it off, 0.955. This There's a lot of like kiwi seeds in this. Oddly, it tastes quite spicy. Okay, 6A. Tree diagram. Tree diagram is really simple. It's my favorite. How many questions? 7. Okay, we're on question 6, right? So box B contains 9 red balls and 5 blue balls. A ball is chosen at random from box A and placed in box B. A ball is then chosen at random from box B. So a ball is chosen at random from box A and then placed in box B. Alright. The tree diagram below shows the possibilities for the colors of the balls chosen. I think you want to see what I'm drinking out of right now. I'm actually drinking out of a half-cut carton of milk because I'm trying to not do the dishes. So, since we finished the milk, so we use the milk as a bottle, as a cup. Okay, 7 red balls and 1 blue ball in box A. So, first one, box A, 7 red. So, out of 8, you have 7 red, so you have 7 over 8 red. And blue, you have 1 over 8. Moving on to box B. So, box B contains 9 red balls and 5 blue balls. A ball is chosen at random from box A and placed in box B. So let's say if you get a red in box A, you will place the red into box B, so you'll get extra red. So 9 plus 1, you have 10 over, what's 9 plus 5? 14 plus 1, you have 15, so 10 over 15. And for the blue balls, you will still have 5 over 15. Okay, red, blue. And then for the other one, if you manage to get a blue, then you will have 9 over 15 chance of getting a red on the box B, and a 6 out of 15 chance of getting a blue at box B. Yeah. Then from this, that's it. That's our tree diagram. Okay, B. Find the probability that the two balls chosen are not the same color. Okay. So probability of the 2 balls chosen not being the same color, we'll have your first one. You will get a red and a blue, so it's 7 over 8 times 5 over 15. Second way to not get same color, you would choose your blue first, so 1 over 8 times 9 over 15. So your answer would be 11 over 30. Okay, number for C. Find the probability that the ball chosen from box A is blue, given that the ball chosen from box B is blue. Okay, so given that the ball chosen from box B is blue, find that the ball chosen from box A is blue. So it will be P bracket, let's just put BA, and BB Ruby. So first one we would do the union of BA, but blue in A and blue in B, which would be, sorry, the intersect. So that would be 1 over 8 times 6 over 15. And then you're below, that would be the probability of you getting a blue in the blue box. Yeah. 6 over 15. No. Well, what goes in the bottom again? I forgot. What goes to the bottom? Okay, so I think what goes in the bottom is the total probability of getting a blue in box B. So total probability of getting a blue in box B would be 6 over 15 plus 5 over 15. So from here we would get 1 over 8 times 6 over 15 over 6 over 15 plus 5 over 15. Over 44. Okay. 7. Cumulative frequency graph. So this one's really like, this is just 3 marks actually. So cumulative frequency, you would have to add up all of this, and adding up all of this gives you 150. So your graph will look something like this, an S shape. And for the values, you actually pick the maximum value. So for 15 you'll have 9, for 14 you will have 15 plus 48, and so forth, so on. Yeah, and then from there, after you draw a graph, 40% of these fish have a length of dcm or more. Wait, I think someone's calling me. Okay. 40% of this fish have a length of BCM or more. So here it already says 40% have a length of D or more. So it's more towards this side of the graph. So first you find what 40% of the fish is. 150 times 0.4, 60. So 60 of the fish should have a length of D or more. So you calculate 60 from here. So 150 minus 60, 90. So from 90 you will draw a line here. Since above here will be the one here would be equals to 60, which is 40%. So and then you from 90 you find the corresponding value. That would be your D. So I can't do this now since I don't have a graph paper. The mean length of these fish is 15.295. Calculate the variance. So for this one, you just do you take the midpoint. For this one, will be 4.5. 4.5 square times 15. So 4.5 square, 12 square, 17.5. Sorry, 17.5 square. Is it? Seventeen square and 25 square times their, of course, their corresponding values. So your formula for variance is the EX squared over N minus the mean square. And yeah, you just do that and you'll get your answer. So let's move on to the mark scheme. Let's start from the bottom. So yeah, like I said, your 40% above, your D will be 90 and its corresponding value, so 16.5. And you would mark your values using the maximum. So we have 30. Let's go back and look at what the maximum value is first. 9, 14, 19, 30. Oh, sorry. So first one, 9, yeah. 14, 19, 30. Yeah. Okay, and then next one, midpoints. Yep, using the midpoints, you would do this, like I said. Yeah, and that gives you a variance. Okay, moving on. 6C. 6/41. So I did get the top part correct, but the bottom part, I did kinda not do the full thing. So I'm supposed to times it by, yeah, the total probability of getting the second ball as blue. So I did get the top correct, but the second one I didn't do it fully. So yeah. Continuing on, B, you get 0.11/30. So that's what I got. And my tree diagram is correct. So that's 3 marks. Mm, 5B, 0.955, that's correct. 0.448458. Okay, that's correct. 4b. Okay, let's take a look at 4b. So, oh, it's identical, yeah. Oh my gosh. Yeah, since it's identical, you would have to times it by the identical candles. Yeah. Okay. Okay. For 4b. Arrangement. Yeah, blues together minus the arrangement of blues together and reds together. So when we think about this, we will just try and make the equation, try to reconstruct the equation out of this. So let's think of it as, in order to get all the blues together, you would have to add the arrangements of blues and reds together, and the blues and reds blues together and reds not together. So that kind of makes sense, does it? Try and make the equation out of this. Yeah, so in order to get your blues together and reds not together, you have to minus your blues together. No, your blues together has to minus the arrangement of blues together and reds together. Yeah, so I guess that kind of makes sense. Okay, so let me just write down the equation. Blues together. This one can be used universally with like other. Okay, we'll just get to the next paper and I might be able to show you. Blues together equals to blues together and red together plus blue together and red not together. For this one, yeah, you place these two R's here, so they are on their place already, so you are not supposed to like think about factor them into your possibility, so you just have the values in between, and since they're identical, you'll have to divide it by, yeah. Okay, moving on. 3a. Standard deviation is 6.48. I did get that. Okay, 3b 0.463. Okay, that's correct. For 2b, I think we only get like 1 hour for paper 5 because that was really quick. 8/27. Okay, for 4/9. 12/27 is 4/9. Yeah, same thing. 2/9 and 1/27. Alright. Continuing on to C, our EX will be equals to 1. Oh, why did I square it? Oh my gosh. It's EX, not variance. Oh. And that's like that's one of my careless mistakes. Okay. For number 1, 38, C 34. That is what I did, so I got the answer. It's kind of weird, you know, because it's like, why is it? What's that? No, this is 1 line. N over NC34. Okay, 38C34, 73815. Okay, 3 marks. I don't know how this can be a mark, but it is a mark. So for 2A, 0.313. Did I get that? Yep, I did get that. Okay, so out of this one, it's easy to calculate the marks that I've lost. So the whole of section, whole of question 4, I got it wrong. So that's quite a lot of marks gone. Section 4 totals to 6 marks. 6 marks. So if we don't count my careless mistake, which definitely we should, that's just 6 marks gone. And that is 44, which is 44 over 50. Just a high A, 88, which is not good. So we can't afford to be making these mistakes. How much time is allocated to this? It doesn't show here, but it does show on the question paper. 1 hour. 15 minutes is just for checking. Alright. Now, I'm just gonna take a break. Just a very, very short break. So, I'm gonna play Destiny. We're gonna complete one Nightfall. Hero mode, since I'm not qualified for Legend mode yet. Since all my characters are 750. Yeah, I'm gonna do one Nightfall, and from there I will continue my paper. So let's wear headphones for this. Let me get my headphones. Because I don't want the sound to be picked up on my microphone, and you would have like 2 different sounds. Okay. Let me just close this book just for a while. We're gonna get back to that later. And I'm going to change the audio to my earphones. Change the audio output to my headphones. Okay, I think you can hear it now. Oh my gosh. Let's hope the Wi-Fi isn't very bad. So I'm gonna play on my Warlock, since I'm trying to... I play on my Hunter way too much already, so I'm just trying to get more stuff on my Warlock. Look at this huge ship. I just got this ship, so I just decided to use it. I usually use like the smaller ship, but okay, that doesn't really matter. Let's go on to... Usually takes like at most 30 minutes for me to do one Nightfall, but usually my teammates are like really brain dead. That's Destiny, I guess. So the Monarch on this Nightfall is actually really good, because it's like, but the fact that it has its own overload for overload champions negates the barrier barrier bulls, the mod that I have on it, which kind of sucks, you know, because I actually need it to like break barriers. But I guess maybe I can ignore that. I don't know, but it's actually really good in the Monarch since in this Nightfall, void damage is increased. I'm just using this grenade launcher just because it's a high light level equipment. I should be using the sword, but I really don't think it's wise to use a sword. But maybe I should, to be honest. But the grenade launchers are really good at clearing as well. And since void damage is increased, then yeah, I guess I should use the grenade. Let's see where I'm loaded into. Oh, okay. Why is it just me? If it's just me, I really can't do this. It's gonna take way too long. Yeah, I really can't do it if it's just me. Since, yeah, there's barrier. Okay. I need barrier stuff to like counter the. Why do I replace my Monarch? Oh my gosh. Okay, I can't do this. There's no point doing this. Let's try and get another match. We need to have people on this. I'm not high level enough to do this. I mean, I'm not as good as those like Destiny streamers who can like solo Grandmaster Nightfalls and all that. Probably need a better. I mean, the Lemon is so great on this, but the fact that it has the overload mod, it negates the barrier mod, which is really bad. Okay. So here I have two new lights. This is not gonna go well. Doing this honestly, I'm just trying to like get better transversive steps. Try and get more of the enhancement prisms or ascendant shards, so I can refine my exotic engram to give me a transversive steps. I don't even think they have any like champion mods. The new lights. I'm hoping they have the barrier mod. Nope, they don't. Oh, they do. Nice. Okay, that's nice. Oh my gosh. Oh my gosh. Okay, that's nice. The thing about new lights is they like to use the, oh my gosh, the basic supers, which is like really good for ad clearing. So that's nice. So the hard part is when we get to the one where we have to deploy our ghosts, because ad clear is really important there, and the fanatics can like one shot you with their crossbows. That's really annoying. And sometimes they spawn you all the way back here. So that's also really annoying. Oh my gosh. Hey. No, this is the hard part. Because there's just like too much ads. Oh no. The best thing to do is like just go back to that corner, but I'm gonna deploy a rift here just to get some extra progress. Oh, I see. The crossbows, they're just too powerful when they get close to you. So you need to like look out for them. Oh my gosh. Just get some area damage on the radius as well. So I'm gonna have to go and get some of the heavy. Just immediately get out. Oh no! Ah. This is too much ads, man. Oh no. Oh man. There's too much damage going on here. Need to get back. Why would you use golden gun? Oh my gosh. You see how fast you can die? Just because of a... Oh my gosh. Come on, man. They just keep spawning. Jeez. What's he doing? Oh, it was going so well. Come on. They just don't go out with me, you know? They need to like advance with me, so yeah, this is too much of them. Come here, man. So where's this champion? We gotta get a few more percentage here and we should be clear. Should be clear now, yeah. Yeah, that was the hardest part. Even the boss play, the boss zone is much easier. There's gonna be like a tons of ads there. No! Yeah, no one's doing ad clear in the middle, so yeah, of course there's a lot of ads. Come on, man. Oh, let me. It's so annoying. They just don't know what to. Why can't they clear? What? How is he dead already? Please, please. Dude, they just. Oh my god, it's so annoying. Why can't they clear the ads? Oh my gosh. Oh, he got it. Nice. I don't think that guy's coming back. Does he not know how to respawn? No, please don't activate it yet. Because if you activate it late, you get a second ult. But yeah, he activated it too early. Dude, what? Oh, hello. Oh no. Okay. Oh, there's too much of them. There's too much of them. Just gonna get this. This in. No, I didn't mean to use it. Might as well take out this champion. Might rift this out. It's gonna have to go and this in here. Okay, I think I can finish this guy. Alright. Pick up the charge. Oh no, there's another one here. Okay. Okay, just need one more. Second. Okay, at least we got it. At least we got it. Oh, I'm not dead. I'm not dead. I'm gonna go and revive this guy. Oh no. Where's... Oh my gosh. Okay, where is this boss? my gosh. We're almost there. Where is this guy? There you are. Oh man. Dude, they're not focusing on the boss. Why is he chasing down? There we go. Okay, this is horrible. Okay, time to go back to my work. Okay, let's move on to the next paper. I think we'll go straight to, okay, let's move slowly. We'll go 2020, October, November. Question paper 5-1. Okay, move away the keyboard. Bring out the book. Okay. This would be 97.951/m/20. Okay, number 1. Find PA intersect B2 ordinary fair dice, 1 red and the other blue is true. The score on the red die is divisible by 3. And B, discuss the sum of the two scores is at least 9. Okay, so the probability of it being divisible by 3 is you would have 3, 6, 9. No, you don't have 9, just 3 and 6 because a die is 6-sided. So you have a 2 out of 6 chance of getting a score that's divisible by 3, and you'll multiply that by the sum of the two scores is at least 9. So in order to get a score that's at least 9, you would need 1-1 wouldn't be enough. 2-2, no. Wait, we might need to draw a table for this, but maybe you can manage. Okay, so the highest number is 6. So 6 plus 1, you wouldn't get 9, so we'll cross out 1. 6 plus 2, you wouldn't get 9. 6 plus 3, you will get 9. So you'll get 3 and 6. That's 2. And then you would have... Okay, let's just draw a table for this. Okay. Let's say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1, 1, 2, 3, 4, 5, 6, 7. So 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11, 12. 7, 8, 9, 10, 11, 12, 13. So we would get 9, 9, 9, 9, 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have a 12 out of 36 chance of getting a sum that's at least 9. So 2 over 6 times 12 over 36 is 1 over 9. So the answer is 1 over 9. So let me just make sure. Okay, should be correct. Okay, moving on. B. Hence, determine whether or not the events A and B are independent. Okay. So, to see if they're independent, we will take probability A times probability B and see if it's equals to the probability of A intersect B. So, I take it back. Sorry, the first one for 1A is not 1 over 9. It's, you would have to find the possibility that the number is divisible by 3 and also the scores are at least 9. So you would have only 2 possible numbers, which would be 3 and 6. And then you would plus them together with 1, 2, 3, 4, 5, 6. So you have 7, 4, 8, 5, 9, 6, 10, 7, 11, 8, 12, 15. So from here you would see that only 1, 2, 3, 4, 5, only 5 are equal. Only 5 out of 2, 4, 6, 8, 10, 12. You can't take it off this, right? So I think, wait. Okay, event B is the sum is. This is hard. Why is this only 2 marks? There's too much possibilities for me to think. Is it? Right, 6 now. 1, 2, 3, 4, 5. Is it 5 over 12 or is it 5 over 36? Okay, so if you think about it, the score on the red die is divisible by 3. You have 2 possibilities. 2 over 6, and then we would take the 3, and in order for it to be more than or at least 9, let's say we get a 3. For it to be at least 9, we will need to get a 6. So you have a 1 out of 6 chance of getting it to be more than 9. So it will be 1 out of 6. And then if you get 6, you would have 4 out of 6 chance of getting it to be more than 9. At least 9. So you have, say, 1 out of 6, and then another one will be 1 out of 6 times 4. 1, 2, 3, 4 out of 6, and from that you would get 1 over 6 times 1 over 6, 1 over 56, and plus 1 over 6 plus 4 over 6, 5 over 6, which is 31 over 36. I don't think that's correct. Okay, but I know we can find possibility of A times possibility of B. So that will just be, you would have, for it to be divisible by 3, you'll have 2 over 6 times probability of it being sum of the two scores is at least 9. From what we calculated just now, it's 12 over 36, which gives us 2 over 6 times 12 over 36, which gives us 1 over 9. And if what we calculated just now is correct, since they are not equal, so we can conclude that it is not independent. I'm really confused about this one. It's A intersect B, so you need it to be both divisible by 3 and the sum of the two scores is at least 9. So I think do we times it? I think it should be correct what I've done. Okay, 2A. The value of X. The probability that a student at a large music college plays in the band is 0.6. For a student who plays in the band, the probability that she also sings in the choir is 0.3. For a student who does not play in the band, there's so much probabilities. Probably that student large music college plays in the band is 0.6. We have 0.6 that play in the band. For a student who plays in the band, the probability that she also sings in the choir is 0.3. So let's draw the tree diagram first. So probably the probability that they play in the band is 0.6, and also singing in the choir is 0.3. For a student who does not play in the band, so we have a 0.4 chance of not getting a student who plays in the band. The probability that she sings in the choir is X. The probability that a randomly chosen student from the college does not sing in choir is 0.58. So yeah, this one's quite simple. Okay, so we know that if they sing in a band, if they're in the band, the probability that they sing is 0.3, so probability that they do not sing is 0.7. So we would have 0.6 times 0.7 plus probability that they're not in the band is 0.4, and we would times it by 1 minus x, because the probability that they sing in the choir is x, so 1 minus x will be they do not sing in the choir, equals to 0.58. So 0.6 times 0.7, you get 0.42 plus 0.4 minus 0.4x is equals to 0.58. So 0.42 plus 0.4, you get 0.82. So we move it to the other side, we get negative 0.4x is equals to 0.58 minus 0.82. And from there we will get 0.58 minus 0.82, negative 0.24, and we divide this by negative 0.4, we will get our x, which is 0.6. Okay, moving on. B. Find the probability that both students play in the band and both sing in the choir. So for a probability of them to play in the band and sing in the choir, it's 0.6 times 0.3, which gives us 0.18. So two students are chosen. Find the probability that both of them play in the band and both sing in the choir. So we found the probability to be 0.18, but we need to be both of them. So we would square this since we need it to be both of them. So it'll be quite a small chance. 0.18 squared. 0.0324. Okay, moving on. 3A. Kayla is competing in a throwing event. A throw is counted as a success if the distance achieved is greater than 30 meters. The probability that Kayla takes more than 6 throws to achieve a success. Okay. Probability that exit is more than 6. Probability 0.25. So if it's more than 6, you would use the formula, since it's more than, you would use, what's that formula again? QR? Or is it QR minus 1P? No, but that's equals. Let me think. More than. I think it's 1 minus QR. I think, is it QR or PR? QR, I think. Okay, so Q is the probability that she won't make it. So it's, yeah, you will take 1 minus probability that she does not make it. Okay, so it's equals to 1 minus 0.756. Therefore, it's 0.822. Okay. Can I make sure of this? Okay, I'm gonna throw away something first. Don't leave your milkshake for too long. let's just move on. For B, find the probability that for a sample of 10 throws, Kayla achieves at least 3 successes. So at least, so more than or equals to 3. For a sample of 10 throws, so this one you would use 10C. So it's 10 throws, so it's too much to go like 3, 4, 5, 6, 7, 8, 9, 10. So we'll just do less than 3. So 1 minus less than 3. 1 minus px less than 3. It will give you 1 minus. For first one, we'll do 0. 10c 0 p r q and minus r. So it will give you 10 plus 10c1 p. At least 3 successes, yeah. 10c1 0.259 1 0.759 plus 10c2 0.252 0.75 to the power of 8. From that we'll get 1 minus 0.75 to the power of 10 plus 10c1, which is 10, but I'm just going to put 10c1, 0.25 times 0.25 times 0.75 to the power of 9. That gives you 0.244, and last one we will do 10 plus 10c2 times 0.25 to the power of 2 times 0.75 to the power of 8. Giving us 1 minus 0.5256, which gives us 0.474. That's your answer. 4A. Draw up the probability distribution table for y. The random variable x takes each of the values 1, 2, 3, 4 with probability 1 over 4. 2 independent values of x are chosen at random. If the 2 values of x are the same, the random variable y takes that value. Otherwise, the value of y is the larger value of x minus the smaller value of x. So this one, the wording is actually just quite tricky. So, I mean, it's quite self-explanatory, but it's just made to sound like really complex more than it really is. So, if you have, so it's just saying that random variable x has four values which are of equal probability of being chosen. So you will take 2 values from x, and if the 2 values are the same, they will take the value. So you could have 1, 2, 3, or 4, but you also need to have 0, because it's otherwise, if the value of y is larger than the value of x minus the smaller value of, the larger value of x minus the smaller value of x. So the probability, you would have 0, 1, 2, 3, 4. That's the 4 probability distribution. And let's say, okay, so let's just firstly count for 0. There's no 0, there's no 0, it's just 1, 2, 3, 4, because it's impossible to get 0, because if you have the same value, you wouldn't minus it, it would just be the value. Okay, so firstly we do 1. So how do we get 1? Either we get both of the same values, so we have 1 over 4 squared, or we get 4 minus 3, which is equal probabilities, 1 over 4 squared again, and then you could have 3 minus 2, so 1 over 4 squared again. So that's all the possible ways of getting a 1. 3, 3, 2, or 2, 1. So 1 over 4 square. That's all. So you would have 1, 2, 3, 4. So 4 times 1 over 4 square. 1 over 4. So 1 will be 1 over 4. Moving on. To get 2, you will need to get 2 2's. So you have 1 over 4 square plus 4 minus 2, which should be 1 over 4 square plus 3 minus 1, 1 over 4 square. Wait, let me think first. I'm thinking like you actually need to take into account the order in which they're picked also. But I'm guessing not really. Since they're still the same, but 1 over 4, because they all have the same probability, so I have to think about this. So is the order important? Because I did just do it previously, but if they're the same. Okay, so maybe you need to take the orders into account as well. So firstly you would have 2. For number 1 again, you will have 2 different ways of getting 2. You could either take like 4 and 3 or 3 and 4. So you have 2 1 over 4 squared. And the other way, 3 2, also you have 2 different ways of getting it. And for 2 1, you also get either 2 first or 1 first. So the new one will be 2 4 6 5. Sorry, 2 4 6 7 7. 1 over 4 square gives you 7 over 16. And moving on, we will have for 2 2 2's or 4 2 and 3 1. So for this one, you will also do it times 2 to do both the 4 2 and 3 1, because they can be different order as well. So from that we get 2 2 5. 5 1 over 4 square, 5 over 16. And moving on, we have 3. So 3 you will get 2 3's, or you will get 4 and 1. Yeah, just 4 and 1, there's nothing else. So you will times that by 2 as well, since there's different orders. So 1 over 4 square, sorry, just do 3 times 1 over 4 square, giving you 3 over 16. And for 4, there's only one way to do it, 2 4's. 1 over 4 square 1 over 16. So that's your answer. So in order to check, let's add them all together. 7 plus 5 plus 3 plus 1, you get 16. 16 over 16 is 1. So yeah, that's correct. Remember, take the order into account as well. For B, find the probability that y equals 2, given that y is even. So for this one, for y to be even, we will need it to be 2 or 4. So we've already found the probability to get 2 or 4, and given that y is even, so yeah, we need to find y equals 2. So it's just, since we found the probability, we'll have 5 over 16 over 5 over 16 plus 1 over 16, which gives us 5 over 6. The time in hours that Levin plays on his games machine each day is normally distributed with mean 3.5 and standard deviation 0.9. Find the probability that on a randomly chosen day, David plays on his games machine for more than 4.2 hours. That 4.2 hours is actually a very long time. Gaming for 4.2 hours, I can't manage that, man. That's like a quarter of your day, because you do nothing for about 12 hours of the day. Like, you sleep for 8 hours, and 4 hours is just doing nothing, eating and all that stuff. I guess that's not counted as nothing, but it's eating and all that stuff. Yeah, so 4 hours. Okay, let's not count it as quarter of your day. It's like one fifth of a day, so that's a lot. 4.2 hours. Damn. Okay, probability of 4.2. Sorry, just do x more than 4.2. So we just do pz more than 4.2 minus 3.5 over 0.9. Since it's standard deviation already, you don't have to square it. So from this we will get pz more than 4.2 minus 3.5 divided by 0.9, we get 0.778. And then from this, we'll just look at MF19, and it'll actually be 1 minus phi of 0.778, giving us 1 minus 0.77824. So 7794 plus 24, you will get 7818. 7818. So 0.7818, that gives you 1 minus 0.7818, 0.2182. So I guess there's a no chance he'll play games for that long. Okay, moving on. B. On 90% of days, David plays on his games machine for more than t hours. Find the value of t. Okay, so px is more than more than t hours. More than t minus 3.5 over 0.9 equals to 0.9, since it's 90%. So in order for it to be more than t and still be 0.9, we will need to get a negative z value. So From this, we would just make sure that it's a negative z value. So 0.9, what do we get for 0.9? It's 1.281. That's the nearest, 0.8999. So it's 1.281. So put negative 1.281 is equals to t minus 3.5 over 0.9. So t will be equals to negative 1.281 times 0.9 plus 3.5. 2.35 hours. Okay, that's good. That's enough time to play games. Calculate an estimate for the number of days in a year on which David plays on his games machine for more than 2.8 and 4.2 hours. C. So we'll just need to calculate the probability that he plays between 2.8 and 4.2 hours. So we've already got the probability that he plays more than 4.2. And then we also have the probability that he plays for not 2.8 though. Okay, we need to calculate that. Okay, so P P 2.8 less than Z less than 4.2. So let's just do this over again. 2.8 minus 3.5 over 0.9 less than Z less than 4.2 minus 3.5 over 0.9. That gives us 2.8 minus 3.5 divided by 0.9 is negative 0.778 less than Z less than 4.2 minus 3.5 divided by 0.9. You get 0.778. From previously, we know that 0.778 is 0.818, so we can just put that in. But from here, drawing the normal distribution curve will really help you with this. But if you want to do it normally, if you know, you can envision the normal distribution curve on your head, then you don't have to draw it. You just say phi of 0.778 minus 1 minus phi of 0.778. So you get 0.7818 minus 1 minus 0.7818. That gives you 0.5632. It will just be 0.563. Okay, move on to the next question. 6. It's another cumulative frequency curve graph. So for a cumulative frequency curve, you would actually just, like I said, take the maximum value, in this case 20, 30, 40, 60, 100, plot it here. So let me see how many questions there are first. 7. Maybe I should do this one. Okay, I'll just do it. Okay, so let's take 6A. So you have the values of 20, 30, 40, 50, 60, 100, and then you would take your cumulative frequency values. Let's just map it out straight away. But if you are doing this, you would have to put it in like intervals like 10, 20, 30, 40, 50 like that. But for me, since I don't have a graph paper, I'll just straight away map out the values. So 48, sorry, it'll just be a curve, S shape. So let's say but you have to go through 0, 0 as well, because if there's 0 time taken, no one takes 0 time to finish a challenge, 0 seconds to finish a challenge. So you have 0, 0, and then you would go up very steep, and then you would start to slow down your gradient. So it's a S shape. So 12, 30, you'll get 48, 40, sorry, not 48, but 12 plus 48, which is 60. And you have 40 plus 60 plus 106, which is 166. 50 plus, sorry, 166 plus 134. Wait a minute, no, this is already turned into a, this already has the cumulative frequency, so you don't have to plus them together. My bad. So it's just 12, 48, 106, and then you have, oh, there's no 50, so you have 60, 134, and 150. Yep. Okay. Moving on. 24% of students take K minutes or longer to complete the challenge. Okay, so for B, let's say K minutes or longer, 24%. So we will take 150 times 0.24. 36. So let's do 150 minus 36. You have 144. So since it says more, so it'll be more towards the right side of the graph. So you take 114 and you just find the corresponding value, and that's your K. C. Calculate estimates of the mean and the standard deviation of the time taken to complete the challenge. So for the mean, it'll be this one. You just take the maximum. Sorry, you don't take the maximum value. You still take the midpoint. So look that this is 20, so it'll still be 0 here. 0 more than or equals to 0, less than or equals to 20. So the middle will be 10. 10 times 12. Plus 20 and 30, the middle will be 15. 15 times 48 plus middle of 30 and 40 will be 35. Oh no, sorry, you can't take the cumulative frequency, by the way. You have to do it by the frequency. So you have to do 48 minus 12, 36, and 106 minus 48, 58. And then the middle of 40 and 60 will be 50, so 134 minus 106 is 28. 50 times 28. And 150 minus 134 is 16. So you plus 60, middle of 60 and 100 would be 80, right? Yeah. 80 times, what value did I get just now? 16. So you divide all of this by 150. This should give you a mean, which is 120, 36 plus 35 times 58 plus 50 times 28 plus, yeah, I put 68, that's 58, 35 times 58, 50 times 28 plus 80 times 16 divided by 150, which gives me 35.8. So the mean would be 35.8. So average is 35.8 minutes. So I actually have to go eat now. My mom's calling me to eat, so I'm gonna go for a bit and I'll come back to finish the rest. Okay. Okay, I'm back. Time to continue. Okay, to find variance, you would take EX squared over N. So it's 10 squared times 12 plus 15 squared times 36 plus 35 squared times 58 plus 50 squared times 28 plus 80 squared times 16 divided by 150 minus the square of your mean. It should give you 15 squared times 36 plus 35 squared times 58 plus 50 squared times 28 plus 80 squared times 16 over 150. $1,685 minus the square of 35.8 squared, which is 403.4. And somehow I think that's wrong. 35.8 squared, 1,000. Okay, it's 403.4, the variance. I guess we'll find out later. Maybe I did something wrong in the calculating of the variance. Let me just check through all my values. 80 squared, 16, 50 squared, 28, 35 squared, 58, 15 squared, 36, 10 squared, 12. Yeah, it should be correct. Okay, it should be correct. Okay. Moving on. 7, 8. Find the number of different ways in which the 10 letters of the word shopkeeper can be arranged so that all three E's are together. So in order for all three E's to be together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. E. 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 factorial. And once all E's are taken, you have 2 P's. So 8 factorial. So 8 factorial divided by 2 factorial, since you have 2 P's, 2 similars. Okay, 8 factorial divided by 2160 ways. Okay, moving on. B. Find the number of different ways in which the 10 letters of the shopkeeper can be arranged so that P's are not next to each other. Okay, so for this one, you find the total probability. Total equals to 10 factorial over 3 factorial times 2 factorial, which gives you 302,400, and you will minus it where the P's are next to each other. So you would have PP 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 factorial over 3 factorial, because the e's are together. There's 3 e's, so 9 factorial divided by 3 factorial. 60,480. So from this you'll minus 302 400 minus 60 480, which should give you 241920. That should be the answer. Let's see. Find the probability that a randomly chosen arrangement of the 10 letters of the word shopkeeper has an E at the beginning and an E at the end. So you have E at the beginning, E at the end, so you're just left with 1 E and 2 P's. So 10 minus 2, 8. So 8 factorial divided by 2 P's together, so 2 factorial, which will give you 20160 ways. Sorry, I think for the first one it's... Oh, this is confusing now. So let's say there's first one, 8 different ways they can be placed together. So 8 times the remaining would be, the remaining spaces be 7 spaces remaining, so 7 factorial over 2 factorial, which will give you it's still the same though, 2160. Well, I guess we'll find out later. Oh, I hate this, man. Okay, for D, find the number of different selections if the 4 letter include exactly 1 P. So you're making 4 letters. There's 2 P's. So exactly 1 P, you'll have 2C1. Times, you have different, you have E's as well. There's 3 E's. Okay, so let's just, I think for this one we can manually do it. 1, 2, 3, 4. So there's 1P, so you have 1P. There's 2 different P's you can put in. What about the E's? What will we do with the E's? What would we do? So let's just use the combination, let's say P, E, and the rest. So no, we will have 2C1, and let's say all of it is E, 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 3C3. So then you would have 5C0. And let's say for another one, we only have one E, so 3C2. Sorry, 2E. So, and then you would have 5C1. And let's say we have two 5s. So 5C2, 3C1, 2C1. And let's say for another one, you have 0, 0E, so 3C0 and 5C3. So that will give us 4 selections, and then we will try and calculate this, which would be 3C3, 2C1, 3C3, 2, 2C1 times 3C2 times 5, 30, 2C1 times 3C1 times 5C2, 60, 2C1 times 5C3, 20. So when we add all this together, we will get 112. Okay. Let's look at the mark scheme. I think that's all right. Yeah, let's look at the mark scheme. MS 5, 1. $15. So you can't really afford to like make careless mistakes here because it's free. Oh my gosh. So we're just gonna count the E's? Oh my gosh. This is depressing. 5C0 equals 1, 5C1 equals to 5, 5C2 equals to 10, 5C3 equals to 10. So I guess they're just, since it's identical, you don't count it in. And you would just count the ones that are not identical. Wow. Well, I get that since it's a fixed number of p's, you don't have to count the possibility in. And they're the same, so. Oh my gosh. Moving on. Oh, it's a probability. Okay. Oh my gosh. Number of ways e's at beginning and end is 8 factorials over 2 factorials. So I did get that correct. And then we have total number of ways, which is 10 factorial over. Okay, so it's 0.667. So I didn't read the question properly, so that's my fault. 241920 for B. No, I did not get 24. Oh, I did. 241920. Yep. So you just take the total number of ways and you put the p's together and the p's not together. And for 7A20160, yep, that's correct. So we just have to manage the arrangement of the 3 E's. Don't have to really care about the rest. Okay, for 6C, yeah, this one's weird because I didn't get the answer, but it's my working spot the same. Yeah, that's really weird. Oh, must have been a careless mistake on my mean. 120 plus 15 times 36 plus 35 times 58 plus 50 times 28 plus 80 times 16. We got that 150. 35.8. How is it 38.2? What? 25. Oh, it's 25. Why did I put 15? Oh my gosh. Don't worry, I know I won't be making this careless mistake during the exam. I hope I don't. Okay. It's 5C. Oh my gosh. I know that I have to times it with 365, but I forgot to do that. But yeah, my probability is correct, so just have to times it with 365. So that's another careless mistake. T is 2.35. Yep, that's correct. 5A is 0.218. K 0.833 for 4B 0.833, which is 5/6, right? Yep. And then so that means our 4A should be correct as well. 7/16, 5/16, 3/16, 1/16. Alright. 3B 0.474, that's correct. 3A 0.75 to the power 6. Oh. Yeah, I guess I got that one wrong. So you just have to remember the, what's it called? The formula for geometric distribution. Geometric distribution formula. So it's all of this. Probably not this. Is this one? No, it's not. No, it's not. The one that I've learned about. Where is it? Something like this, I guess. Yeah, if it's equals, it's qx minus 1p. Well, what about the rest? What's the rest? Is it this one? No, it's not. Oh, where is it? Because I totally forgot about it, but you need to refresh up on that. I need to refresh up on that. Where is it? Hold up. I'll ask one of my friends to send the notes over. So it's like, if it's more than, it's QR. From what we've seen here, more than is QR. Less than will be 1 minus QR minus 1. And then more than equals to will be 1 minus QR. And less than equals to will be QR minus 1. So I might have to write it down. If it's more than, it's QR. Less than, it's q to the power of r, and then less than, it's qr minus 1. Sorry, 1 minus qr minus 1. Wait, sorry, my friend just sent it. So I think I'll show it to you. If I can find it. If you send the correct, I think it's this one. Alright, so I'll show it to you. Just give me a second. Hold up. So you have to remember this one. Let me just change my OBS to different capture. Okay. So if it's equals to, it's QR minus 1p. And if it's more than, it's QR. If it's less than, it's 1 minus QR minus 1. And if it's less than or equals to, it's 1 minus QR.